of 3.1. And h is differentiable. This is its derivative, and whose first derivative is given. How many real solutions can we have for h of x being 0? Well, the slope is 0 of this, because this tells us the slope. It's 0 in the middle, and it's the value of the slope is negative, so the function is decreasing, has a slope of 0 in the middle, and then over here it's all positive, so it has to be increasing. So the function must come down and go back up. Negative slope to positive slope, 0 slope in the middle. So it could be up high, or it could be down here, or it could be just touching here. So it could have, how many solutions can this equation have? Well, it could have 2 on either side, and they'll be equally spaced. So when it asks, what's the sign about them? Well, if this crosses somewhere here, over here, like maybe at 3, the other one will be at negative 3. So the two solutions will be equal and opposite. Okay, now it says, assume that as you go towards infinity, that the slope gets closer and closer and closer to 3. May not never touch it, but it gets closer. And the limit, it's 3. Well, that means on this side, the slope of your f, if it was something like this and it went through 3, the slope will get closer and closer to being 3. So it'll get closer and closer to being a straight line here. And if you look at the other side, on the other side, it's going to get closer and closer to negative 3. And that's kind of what they want you to see about that. How about the concavity? Well, it's always concaved up. It goes from a double prime, goes from I got to be careful how I say this. The derivative of this, the slope is pretty much close to 0. Then it gets, but it's close, but it's positive, and then it gets bigger, big positive, and then it goes back to down here. So the second derivative is always positive, which means this is always concave up. Okay? 7. Construct the second derivative sign chart. Well, if the second derivative is this, it's 0 at -1, and it's 0 at 2. This can never be 0 because the ln, or the e to the x curve with a minus is always going like this. It's always positive. So the only thing we really have to be worried about is this, and below -1, like -2, this is negative, this is negative, 2 negatives make it positive. So it's concave up. In between -1 and 2, 0, let's say, this is positive, this is minus, and that's always positive, so it's going to be negative, and so it's concave down. And then here above 2, that'll be positive, and that'll be positive, and that's always positive, so it's positive, and so it's concave up. So there's a second derivative sign chart. Now suppose you know that this is a critical number of p. So that square root of 5 is about 2.2 minus 1, 1.2 cut in half, about 0.6. 0.6. So over here, someplace, 0.6, it's the slope is 0. F prime equals 0. We'll have a local max or min. Well, let's see. The slope is 0 and the concavity is negative. So it's concave down and the slope is 0. So that means it's a local maximum. And then it says, find the equation of the line. Well, the line, L of x, tangent line, at a equals, they said, 2. So we need the slope at 2. Well, at 2 p prime, the slope is negative 5 over e squared, x minus a, time plus f of 2. Oh, and they said the point is this, so it's plus. It's 12 over e squared.